All right, welcome back, everybody. So as I was telling the class in here, just as a reminder, the ornaments are due on Monday. That's 5 bonus points, 5 summative bonus points. I know some of you guys kind of want a little bit of a grade boost, and that's there for you. I've had students, I've got one already. Look, this nice little, she did her little paragraph about a cube. Oh, kind of broke it. But anyway, so ornaments are due on Monday. Just to kind of run down this week and next week for you, remember that today and tomorrow we're doing section 5-7. There's no new guided notes tomorrow. We're just going to do a couple of extra problems. We had one extra day with these sections 5-7, 5-8, 5-9 stuff. So we decided to put one extra day within the 5-7 material because it's a little bit more difficult than the 5-8, 5-9. We're actually going to do things a little out of order. We're going to do section 5-7, then we're going to do section 5-9, then we're going to do section 5-8. So section 5-7 is all about quadratic inequalities. Section 5-7, 5-8, and 5-9 are kind of like weird things that don't fit in the first half of the chapter. That would be like the title of the second, these 3 sections. Weird things that don't fit in with the first half of the chapter. Like 5-7 is quadratic inequalities. 5-8, something completely different, quadratic regressions. Remember how we did like the list 1, list 2, and we did that thing in our calculator with lines of best fit? We do that same thing with quadratics. We'll do that in section 5-8. And then section 5-9 is operations. Remember all those complex numbers, that a plus bi thing? We do operations with that. So we add, subtract, multiply, and divide complex numbers. That's section 5-9. So these weird 3 sections that kind of don't fit in with the first half of the chapter, that's what we're going to be doing, sections 5-7, 5-8, 5-9. Know that there is no assessment over these 3 sections. The only assessment we have really over these 3 sections is just going to be on the exam, okay? Now, we're going to do section 5-7 today and tomorrow. We actually jumped to section 5-9 on Thursday. Because in our opinion, section 5-9 is a little bit more difficult than section 5-8. And then we do section 5-8 on Friday. There won't be any homework over section 5-8. The homework over the weekend is going to be the exam review. And it'll just be due on Monday and Tuesday. Half the exam review is going to be due on Monday, and then the other half of the exam review is going to be due on Tuesday, a week from today. And then we take our exam Thursday, Friday in here. And then we don't do anything for 2 weeks. We relax. Hopefully. All right. Quadratic inequality. Okay, so we've graphed quadratics, right? In section 5-2 or something like that, we learned all the things that we need to possibly do to graph quadratics. But what if I call it an inequality? Well, think about all the things that we learned about inequalities when graphing. Right? Well, that means we got to do the whole dotted or solid thing. That means we got to shade, right? So all of that stuff is going to tie in. So it's not necessarily new material. Well, there's one part that's new, that's solving by algebra is new. But the graphing piece is not necessarily new. We know how to graph quadratics. We know how to graph inequalities. So all we're going to do in this first part of the lesson is just graph quadratic inequalities. We're going to put those 2 pieces of information. We're going to put those 2 things together, add those 2 concepts in. In lesson 5-2, we solve linear inequalities, 2 variables by graphing. We can use the similar methods to solving quadratic inequalities. To graph a quadratic inequality, we basically, 3 steps, graph the parabola that defines the boundary, right? And we did this with equations as well. We graphed the boundary line. We found the slope, we found the y-intercept. We graphed the boundary line. In this case, the boundary line is going to be a quadratic. It's going to be a parabola. Second step was we used a solid or dotted line. So same thing, solid or dotted line. Same rules apply. Or equal to's means solid lines. The not equal to's means dotted lines. And then we just shade. Now, instead of doing the whole above or below thing, I don't like the above or below rule here. I like to pick the test point, right? I like to pick the test point. And we did that We did that a little bit, but now it's going to be a little bit more important because it's going to be more of like an inside-outside thing rather than above or below. So enough of me yapping about it. Let's do it. Graph the quadratic inequality. Y is greater than or equal to x squared minus 7x plus 10. Okay, so let's think back to everything that we know how to do to graph. First of all, does this open upward or does this open downward? Up, because A is positive, right? I see a positive 1x squared, so this opens upward. Okay, so we know that this opens up. Let's figure out where the axis of symmetry is. Remember, the formula for the axis of symmetry is x equals negative b over 2a. X equals negative b over 2a, where a is 1 and b is negative 7. So that's going to give me negative 7 over 2 times 1. So positive 7 over 2. So let's say, okay, 7 over 2 or 3.5. That's not what's coming and attacking us here. Whew. So x equals 3.5, right? Negative b over 2a, positive 7 over 2 times 1. All right, so 3.5. Let's go in right now. We know that this is going to open upward. Let's go in and put in, I like to do a dotted line. Understand that this is an inequality, so I'm going to erase away that dotted line in a second. But it's at 3.5. 1, 2, 3.5. Right in there. I know that's the center line of my graph. Okay, so where's the vertex point? Well, the vertex point is going to be 3.5 comma something. So let's plug in 3.5. 3.5 squared minus 7 times 3.5 plus 10. Negative 2.25. Negative 2.25. I should really be using fractions, but whatever. Well, we're all right. So 3.5 comma negative 1 2.25. Right down there. Okay, so we know it opens up, and we know there's my vertex point. Where is my y-intercept? 0 comma what? 10. Right? 0 comma 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 3.5 units away. 3.5 units away. Oh, right on the dot there. Okay, now this is where we would have stopped, like on the test yesterday, right? But since we've gone through sections 5.1 and 5.1 through 5.6, we've gone through all of that stuff to figure out the zeros. You want to figure out the zeros? Let's figure out the zeros. Let's see where it would be, right? Let's why not, right? We've learned how to do it. Let's do it. Let's figure out where the zeros are. Oh, sweet, this one's factors. Nice. Factors of 10 that had to get to negative 7, negative 2, negative 5. So that means my two zeros are x equals 2, x equals 5. Okay, so that, we're just trying to gain more information, right? We're just trying to, see if there's anything else that we can do to correctly graph this thing. So 2, 3, 4, 5. It just paints us a better picture, right? The more detail we can get, the more accurate we can be. All right, so I pretty much figured out where my boundary line is, right? So now I decide, is this going to be a dotted or solid parabola? Is this going to be dotted or solid? Solid, because there's an or equal to. Okay, so I'm going to graph that in now. Do the best you can to be as accurate as you can. At this point, I'm going to go in and erase away my axis of symmetry. That looks weird. Okay. And now I have to decide where to shade. That's the last piece of graphing an inequality. Where am I going to shade? Well, the best thing I think to do is to pick a test point. And I love to pick 0, 0. Do we all see that 0, 0 is on the outside of the parabola? So let's see if 0, 0 works. Let's run 0, 0 through this equation. 0 is greater than or equal to, well, okay, this is just my y-intercept, right? 0 minus 0 plus 10. Is 0 bigger than 10? Not the last time I checked. So therefore, 0, 0 is not shaded. The opposite region is shaded. And in this case, that's the inside of the parabola. There we go. Now, do we understand that anything that I just shaded, any coordinate that I just shaded would be a solution? Like the solution is actually a picture, right? The solution is actually an area here. Anything in the blue region would be a solution. 4, 0, 3, 0, 3, 2, whatever. Questions on that? Okay, you guys try graphing the next one. I'll give you a head start. I'm going to start showing the work up here. Watch out. The axis of symmetry should be -1, right? -1, not +1, but -1. Watch out for that. -1. There's 3 negatives in there. Negative from the original equation, the negative in my b value, the negative in my a value. So there should be 1 left over. 1 doesn't cancel out. Okay, so my axis of symmetry is -1. Let's figure out what this is. -1 comma what? Let's figure out what this is. -3 parentheses -1 squared minus 6 times -1 minus 7. -4. -4. -1, -4. And then I know my y-intercept is -7. Okay, let me ask you this. Should I even attempt to find zeros? No. because it's not actually going to cross the x-axis, right? I can see that right now. It's going to open downward. The vertex is below the x-axis. The y-intercept even shows me more that it's going to not cross the x-axis. So I'm not even going to attempt it. What would I get if I had tried to find the zeros? I'd get non-real, right? I'd get an I, right? Okay, so I'm not even going to attempt it. Is this a dotted or solid line? Dotted. See, everything up to this point right now has been reviewed. This is the new piece where we start making it dotted. I'm going to erase away my axis of symmetry here, so it doesn't look like any sort of dotted line that was associated with the parabola. And now I shade. Let's shade. Oh, we got to pick a test point. Forgot to pick a test point. I'm going to pick 0, 0 again. That's an easy one. 0 is less than, this turns to 0, this turns to 0, -7. Is 0 less than -7? No. So it's not on the outside where 0, 0 is. I shade on the inside where 0, 0 is not. Okay, you get the idea. Any questions about that? Okay, so this is graphing them. But what if I replace a number with the y value, right? What if I said that like 5 was less than -3x squared minus 6x minus 7? Or what if I replaced it with an expression like 2x plus 5 is less than -3x squared minus 6x minus 7? How would we solve it that way? How would we solve algebraically? Well, I can solve those things in two different ways. I could solve it by graphing. I'm going to show you how to do that on your graphing calculator. I could solve it by graphing, or I could solve it algebraically. Take a look here. Quadratic inequalities in one variable have solutions in one variable that are graphed on a number line. So what we can do is, we're just going to go straight to algebra. We're not even going to talk about the graphing. Just want to make sure. Yeah, we're just going straight to algebra. Excuse me. We could do it by graphing. I could show you where it would be on graphing, but you don't want to do that because it's inaccurate. It's like solving a system by graphing. Does it always work? No, but does it work a lot of times? Sure, but that's only when it crosses at a nice point, right? So there's got to be some more algebraic way to do it. Okay, let's take a look here. Solve the quadratic inequality by using algebra. We're going to do a special technique that you're going to use not just here, but in pre-calculus and organic calculus. Okay, it's this thing called sign analysis. Because obviously what we've got here, let's kind of analyze what's happening here. If I were to graph this thing, I would have a quadratic that opens upward with a y-intercept of 10. This is the same thing, is it? Oh, it's very close to our example A, but it's just a little bit off. It's a quadratic that opens up, and then, a horizontal line at 2, right? If this equals 2, I would have like a horizontal line coming across at 2. And I would say, okay, there's a point here and a point here that's the threshold. That's where the parabola starts to dip below that horizontal line. And I want to know when the parabola is greater than 2. So I would say, well, it's all points over here, and it's all points over here. But there's these two dots that are thresholds there where it crosses below and above. So our first thing that we have to do is figure out where those thresholds are. We have to basically figure out where the intersection is there. Kind of like a system of inequalities. Or system of equalities, system of equations. I basically have to find this. When is that going to be true? Because that's going to give me what I call my critical values. The places where the sign changes. It goes from being positive, or it goes from being greater than to less than, right? It's where it switches. Oh, well, to solve this, I just subtract over the 2, and I solve. By any means necessary. Did I say to use a specific method? No. You can do whatever you want. Guess what? Factors. Factors of 8 that had to get to negative 6 or negative 4 and negative 2. X minus 4, X minus 2. So that means I've got X equals 4 and X equals 2. So those are the X values that are the critical points to this inequality. Okay? So here's the technique. Here's the cool piece about this, is that I could graph this kind of like on a number line, where I can put my critical values of 2 and 4 on that number line. And I can see where my solutions are going to lie by picking test points. Okay? I'm basically just running values and seeing, okay, when is this going to be a true statement and when is this going to be a false statement? I pick my 2 critical values, and then I take what's called a sign analysis, where I see, okay, is it going to be greater than or is it going to be less than? Is it going to be a true statement? Is it going to be a false statement? Okay, so take a number less than 2. Like thinking about it on a number line, the easiest number to plug in less than 2 is going to be 0. So let's plug in 0 and see what happens. What's the easiest number to pick between 2 and 4? Let's pick 3 and see what happens. And let's pick a number above 4. Let's say 5. And see what happens. Now, what do I mean, see what happens? I mean, let's plug those numbers in to the inequality to see if it's a solution or not. Okay, so let's plug in 0. Well, that's going to get me a 10 on the left side. Is greater than or equal to 2. Is that a true statement? Yeah, that's a true statement. That means that there are solutions to the left of 2. Let's try 3. Let's plug in 3. Okay, 3 squared minus 6 times 3 plus 10. That gives me 1. Is 1 greater than or equal to 2? Not the last time I checked. So there's a no in the middle there. There are no solutions between 2 and 4. 2 and 4 are the critical values. So we arbitrarily pick a number between them, say 3, just to see what's happening, if whatever in between 2 and 4 would be a solution or not. It's not. And then we run 5. Let's run 5. 5 squared minus 6 times 5 plus 10. 5. I get 5. 5 is greater than or equal to 2, which is a yes. That is a true statement. So what is that telling me? That's telling me that the solutions lie here and there. What type of inequality did I just draw? Which ones point out? Ands or ors? Ors point out. Ors point out. So we say x is less than or equal to 2, or x is greater than or equal to 4. And that's my answer. You have to go through the sign analysis. You have to go through, where's it bigger, where's it smaller? Okay. The difficulty of these problems depend on how difficult the quadratic is to solve. Okay, this one was an easier problem because the quadratic was pretty easy to solve. It was factorable. Let's take a look at this one. Negative 2x squared plus 3x plus 7 is less than 2. Okay, so we're going to solve this algebraically. I'm not even going to attempt to look at the graph for this one. Okay, I know there are 2 critical points where I guess I shouldn't say I know that there are. I think that there probably are 2 critical points where this quadratic is crossing 2. So let's see where they are. Let's find our critical values first. Negative 2x squared plus 3x plus 7 is equal to 2. Let's figure out where this occurs. Okay, well, let's subtract over the 2. Negative 2x squared plus 3x plus 5 is 0. Okay, so now we go through the process of trying to see what our best route to take is in terms of solving the quadratic. Okay, people, do I want to try to complete the square? Ain't no way. I mean, I guess I could try to factor, but I have seen from grading your tests and your quizzes from the past that you guys don't love when you've got to try to factor with a number out front. Can't we just do the quadratic formula? Let's just do the quadratic formula. Let's see what happens when we do the quadratic formula, because I don't want to attempt to try to factor if it doesn't factor in the end anyway. X equals the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Okay, so a is -2, b is 3, c is 5. All right, so -3 plus or minus the square root of b squared, which is 9, minus 4 times -2 times +5, all divided by 2 times -2, which is -4. Okay, let's go to my calculator and start chipping away at the discriminant. 9 minus 4 times -2, oops, that's 5. -2 times 5. 49, sweet. Sweet. Oops, -4. Look, is it 49 square rootable? So I would say -3 plus or minus the 7 over -4. And I can actually get two values here. -3 plus 7 over -4, -3 minus 7 over -4. Now, if you end up not getting a perfect square, you have to go through the process to find the decimal. If, say you got like the square root of 48, you would have to figure out what the decimal value of the square root of 48 is. Because you need to figure out where it goes on a number line so that you can tell the test points to pick. Okay, at this point, we're not really too concerned about exact value there because we need to figure out where those 2 points are on a number line. Like here, I actually have to run the numbers and say -3 plus 7 over -4. Oh, that's -1. And then I have to say -3 minus 7 over -4, 2.5. Because I've got to figure out where this goes on a number line. -1, oops, I like to put my critical values above. -1 and 2.5. Okay, so at this point, those are my critical values, those are my critical points. Let's find our testing values. Our values that I'm going to pick to see what's happening. So something to the left of -1, let's say -2. Something in between -1 and 2.5, let's say 0. And something above 2.5, let's say 3. Okay, if I plug in -2 here, that's going to get me -2 times -2 squared. Plus 3 times -2 plus 7. So -7 is less than 2. Is that a true statement? Yeah. So this is a yes. Let's run 0, but 0 just gets me my y-intercept. So that's going to be 7 is less than 2, which is a no. If I plug in 3, let's see what happens when I plug in 3. -2 times 3 squared plus 3 times 3 plus 7. -2 is less than 2, which is a yes statement. So that means my solutions, now these are open circles, are over here or over here. And wherever I get a yes, that's where the solutions are. So we can say x is less than -1. Oops, sorry, -1, not -7. What am I doing? -1. And so since these point out, I'm going to say or x is greater than 2.5. If it were to point in, you would just write it as an and inequality instead of an or inequality. Questions there? Okay, let's do one more. Let's do a word problem, something that comes out real funky. Shall we? Real funky. The monthly profit P of a small business that sells bike helmets can be modeled by that function, where X is the average selling price of the helmet. What range of selling prices will generate a monthly profit of at least $6,000? So this is kind of interesting here. You know, it's saying that this function is modeling their profits. So this function, this negative, and I'm just kind of sketching here, this quadratic is modeling their profits. So there's somehow, and I don't know what the outside context is, there's a threshold, there's a peak value that if I start producing more, maybe my profits go down. Maybe the quality goes down or something like that. There's other outside factors that are going on that would make my profits take a downturn. Maybe you know, my supply gets decreased so much that it drives down demand because people keep coming and there's no stock, so they just stop coming or something like that. There's something that makes my profits downturn, some outside factor that's doing that. Okay? I'm not really concerned about that. What I'm concerned is saying, okay, so there's this profit line of $6,000. I want my profits to stay above that. So I want to find the values that are going to make that happen. Right? That's what I'm really looking for. Okay? So basically I'm saying negative 8x squared plus 600x minus 4,200 has to stay above, greater than or equal to 6,000. You guys follow me there? I'm just saying I want profits greater than or equal to 6,000. All right, so what do? Well, I do the exact same thing that I did when I solved it by algebra. I want to subtract the 6,000 over to the other side, negative 8x squared plus 600x. And again, I'm setting it equal to 0, so I take negative 4,200 minus 6,000. There we go. And I get negative 10,200 minus 10,200 is equal to 0. Okay, I don't know about you guys, but I don't really want to graph or try to complete the square or even attempt to see if this is factorable. Let's just put this into quadratic formula. Yeah. I know the numbers are big, but that's okay. We can deal with big numbers. That don't scare me. A is negative 8, B is 600, and C is negative 10,200. So the opposite of B, plus or minus the square root of B squared minus 4, A, C, all over 2A. Just double check you plugged it in right. Negative 600 plus or minus the square root of 600 squared minus 4 times negative 8 times negative 10,200, all divided by negative 16. Okay, so I go inside my radical, I go to my discriminant, and I say 600 squared minus 4 times negative 8 times negative 10,200. 600 squared minus 4 times negative 8 times 10,200. Okay, 33,600. Now, I don't know if this is a perfect square or not. I see 36 in there. Maybe it is. But I don't really care. I want to find the decimal values because I'm talking about price anyway, right? I don't want a square root in terms of price. That's not going to make any sense to me. So I'm just going to find the decimal value. I'm actually going to square root it. Okay, it's not a perfect square. 183.30. And I'm only going to round to the nearest hundredths because, again, it's money. So this is negative 600 plus or minus 183.30 divided by negative 16. And now I'm just going to find my two numbers. I'm going to find my two values. I take negative 600 plus 183.3 divided by negative 16. So 26.04. 26.04. And then, so I did the plus, let's do the minus. Negative 600, oops, sorry, negative 600 minus 183.3 divided by negative 16. 48.96. Okay, so those are my two values, right? I saw graphically that I'm going to want to stay in between those values, but let's take a look at the sign analysis to see what's going on, to see what this looks like, because this is going to be one that's different from the two problems that we've already had examples of. We have a 26.04. Oh, I'd like to put them on top. Nested values go on the bottom. 26.04, and then a 48.96. So let's run three testing values. Let's say here, here, and here. Well, the best testing value I can get below 26.04 is 0. Let's say in between, I don't know, let's go with 30. Nice round number in there. And something above 48.96, let's go with 50 and see what happens. Okay, so all I need to do is just run the numbers here. I go to 0, and this would be negative 4,200 is greater than or equal to 6,000. Well, that's not true. That's obviously not true. Let's run 30. Negative 8 times 30 squared minus 600 times 30 minus 4,200. Okay. Something is wrong. Oh, I forgot. That's a plus in there. I did a minus. Plus. That's more like it. 6,600. 6,600 is greater than or equal to 6,000, which is a yes. And then I run 50. Let's go 50 instead of 30. And I get 5,800, which is not true. 5,800 is not bigger than 6,000. So that's a no. So we've got a no, yes, no in this case. So my solutions are only in between, and I use solid dots because this is an or equal to. My solutions are only in between there. So what does that mean? That means that it's between 26.04 and 48.96. That's the range of values that will keep my profit above $6,000. I don't want to sell my bike helmets for any less than $26.04. I would not get the profit that I need. I don't want to sell my bike helmets for more than 48.96. Oh, this makes more sense now. Because this is the profit as a function of how much I'm selling the bike helmets for. So obviously, if I price out my bike helmets way too much, then my profits are going to go down because they're just too expensive. There's better options out there for cheaper. Okay. So this is these are the range of values that would keep my profits above $6,000. All right. I hope we're all having a great day, folks at home. I will see you later.